And thank you very much for joining us. Today I have a very special guest. We have Thorben Janssen with us here, expert in Java persistence and in Java in general. And I'm very happy because we were going to learn a lot of things, especially about Hibernate databases and other persistent features. Thorben, thank you very much for joining us today. I'm very happy you're here.
Yeah, thank you so much for inviting me. It's my pleasure to be here.
Thank you very much. I'm so curious about a lot of things related to Java persistence, and I'm pretty sure I'm going to learn a lot of stuff. Friends, if you are here with us live, remember you have a live chat there. I'm going to keep an eye on the live chat, and I think Thorben as well. Anyway, otherwise I will ask the questions. No worries. And we are going to have an excellent discussion. Thorben, the persistent or persistence layer of an application is so important, no? Because I think there is almost no application without persistence. So firstly, what should we consider when we decide what to work with? We have so many options. We have JDBC, we have Hibernate, we have any other JP implementation, we have Juke. What should I, as a developer or architect, take into consideration?
Yeah, I think there are two things you should take into account when picking a framework. First of all, I think one very important question is there a framework your team is already familiar with? Because if you have very strong tech skills in your team on one specific framework, then you're very likely to produce a higher quality persistence layer using that framework than using something that's completely new, right? But at the same time, that of course shouldn't be the only thing you take into consideration, because you said it, there are lots of different frameworks you can choose from, and each of them has their different strengths and weaknesses. I'm doing many projects using Hibernate or Spring Data JPA, which are, well, all based on the JPA specification, so the Jakarta persistence specification. And that is an implementation of an object relational mapping framework. That means it maps records in the database to Java objects, and is very good in traversing associations, yeah, performing insert and update operations just because you created objects or modified objects. And it does many things for you you don't need to worry about as a developer. But that, of course, also has a few downsides, because there's lots of magic going on that might be hard to understand. And all object relational mapping frameworks are very good in implementing standard CRUD operation, everything that's focused on single records. But they are not that great when working with complex queries that need to extract information from your database, stuff like that. In that case, plain JDBC or Juke are a much better fit, because there you have all SQL features supported by your database available, and you can use them to extract exactly the information that you need. So there the question is, what do you actually have to implement use case-wise in your application? Is it something that's more UI-driven, where you have mostly CRUD operations and just a few very complex queries? Then JPA, Hibernate, Spring Data JPA, one of these three is a good fit. If you have to implement something like, I don't know, a management dashboard, something that has to perform lots of complex queries, but not that many CRUD operations, then something like Juke or plain JDBC, or maybe JDBC templates in the Spring context is a much better fit, because there you're closer to the actual SQL statements. And then, of course, we still have Spring Data JDBC, which is an object relational mapping that is different than Spring Data JPA, because it's not based on the JPA specification. There you have much more control over the executed statements, so that means less magic in the background going on, and a very strong focus on domain-driven design concepts like aggregates that group multiple entities together. I would say that is a great pick if you already know that you want to strongly focus on domain-driven design principles when implementing your application. Then that is something that is very close from a persistence point of view to the to all these concepts in general.
Super. One thing is that whenever a developer asks me about Hibernate, they tend to tell me also about the complexity of the things behind the scenes. So they start considering the thing easy, but then they find out that it's not such an easy learning curve. So what would be a best approach, or the best approach, or one of the good approaches for a developer to learn Hibernate if they begin now with the framework?
I would say the best way is to get a resource that teaches you about the concepts in a structured way, because there are some that are not visible from the outside, and it's extremely hard to learn something on your own if there are features that are important but not visible because then you don't know what you need to learn about, right? I mean, we at least have to know that there is something we need to research and learn about. So yeah, any book about Hibernate, maybe get a training. Maybe if you want, take a look at my Persistence Hub. There's a beginner's course and advanced courses about that as well, of course. And yeah, if you pick a good resource there, they will guide you on the way and teach you much more than you pick up in Stack Overflow discussions or the average blog post that you can find out there, of which I've written tons of myself. So I know there are lots of good resources out there on various websites, but the downside of blog posts is that you usually only find and get what you were searching for, which is difficult about if you totally unfamiliar with this stuff. And see, Carlos asked in the chat, what about the official documentation? Yeah, it's definitely worth it. The documentation is good. There's lots of it available. You can also take a look at the Jakarta persistence specification, for example. All of these are good resources. The thing there is that in my experience, it's a little bit difficult to just take a look at the specification or the documentation and then learn the things in the right order if you don't have someone there that makes sure to connect the things you have to know. But yeah, to be honest, I started with the specification and the documentation when learning about Hibernate and JPA. I don't know, with Hibernate about 20 years ago. And then it's important that you learn about the lifecycle model, for example, that's in the background. That's something that many developers don't see when they start out with Hibernate. I ran into the same issue, as I said, when I learned Hibernate about 20 years ago. It's something that you don't see, and it affects all write operations executed against your database. And it's the reason why we are still using Hibernate, even though it's such an old framework, because it ensures that just a call on a setter method of your entity object doesn't immediately trigger an update statement. It groups statements together and allows your JPA implementation, for example, Hibernate, to decide, okay, now I have to execute an update because we commit the transaction, for example. Let's check what managed entities we have in our current session. And which of them have changed, and then execute the update statements for them. And all of these are, one element of the whole lifecycle thing.
I do remember my experience was a little bit different because I first discovered the JPA documentation, and it was like a 600, 700 pages PDF on the internet, and that was huge, and I felt it didn't help me. So I read a couple of books, and then I really felt that I can understand it. So it was a little bit cumbersome for me at the beginning, that document, before reading a little bit of more structured way. And about that, about books, I see you have your book there in the back. Is that something that you'd recommend to what kind of developers?
I would say you should have some experience with Hibernate. You shouldn't start out with it if you don't have any experience with it. So what I do there is I'm presenting lots of different recipes how to solve different things. Um, yeah, the intention of the book was you can have it on your desk as a physical book, as an ebook on your desktop, and if you run into something during your day-to-day work that you want to solve and you don't know exactly how to do it, then you take a look at that book, and then you have a very short tutorial that shows you exactly how to implement one specific thing. And well, I hope that this book works for most developers in that way, but I'm pretty sure that if you want to get into Hibernate, this is not the right way to start you. There you need something that more connects the bigger parts and guides you on in the right direction through the most important things.
But it's still
And
essential. No, I mean, well, you start with the easiest books, then you got the documentation, but you don't forget to also read the Hibernate tips from Thorben, okay?
sounds great. And yeah, as you said, the documentation, no, the specification is a huge document. And yeah, in the past, it was really hard to read. I feel like the newer versions of the specifications are much easier to read than the older ones. And I hope that someone who's not been working with Hibernate to the extent that I have for the last, I don't know, decades, thinks so as well. But I would say the newer versions of the specifications are much easier to read than the old ones.
We also have a question now. So from Jack, what do you think about the alternatives to Hibernate, like Spring Data JDBC or Juke? You already told us a couple of questions.
Yeah, that connects a little bit to our starting topic, right? So yeah, Spring Data JDBC. Um, if I remember correctly, Jens Schauder, the main developer working on Spring Data JDBC, told me in the beginning that his intention was to do yeah, an object relation and mapping framework with less magic than we have with Spring Data JPA. And I would say he achieved exactly that. It is an interesting approach if you want to follow domain-driven design principles, because all of Spring Data JDBC is based on aggregates as they are defined in domain-driven design. So the idea of an aggregate is that it's a group of entities that belong together logically, best case in the real world, and that you read and write them as one thing. And that is something that, well, is ingrained in all these in the entire domain-driven design world, and creates some issues when working with relational databases, because there you might not really want to write or read a group of 5 or 6 records as one thing all the time. And that is why these domain-driven design concepts are maybe a little bit difficult to follow when using Spring Data JPA or Juke or any other framework. But I think that Spring Data JDBC handles that quite well, as long as you keep your aggregates small and concise. Juke, on the other hand, follows a totally different approach. There you have a great DSL for the SQL language. And I think that is an amazing framework. Lukas Eder did a great job there, because using it, you can write a SQL statement as Java code, basically, or it at least feels like that. It looks like that. And he used generics and other Java or JDK core features in such a great way that your IDE with syntax completion and everything and strong typing actually helps you writing the SQL statement. So I would say I'm able to write better and more complex SQL statements using Juke than I would be without it, or with just writing a SQL statement as a string. And using that makes great sense if your application requires lots of complex queries. So I would say if you are implementing mostly CRUD operations that are maybe driven by a user using a UI, you get great results with in shorter time when using something like Spring Data JPA or Hibernate. But you will fail, or at least struggle, if you have to implement lots of complex queries. And Juke is not entirely, but a little bit the other way around. You can, of course, use that to implement CRUD use cases as well. It will just take a little bit longer and more work than using an object evaluation and mapping framework. But it's amazing if you want to implement complex queries and extract data from, or information from your data in your database.
I hear sometimes developers saying that if you use a framework such as Juke or Hibernate, you don't need to know SQL anymore. Is that right?
No, definitely not. Well, if you're using Juke, you have to know SQL because you're basically writing SQL in Java code. And well, you could think when using Hibernate or Spring Data JPA that you don't need SQL anymore because, well, you just have entity objects, right? And you maybe write a repository method that fetches you the required entities from the database without writing any statement yourself. You just define a method name and Spring Data JPA does the rest for you. Well, yeah, that might work for simple use cases on small databases, but it's just the beginning of lots of performance problems when you deploy that to production and put it on a huge data set. Because all that Hibernate does is, in the end, a set of SQL statements sent to the database that are insert, update, delete statements, and of course, lots of select statements. Hibernate can generate all of these for you, but if you are not able to read them and understand what they are doing, then I'm pretty sure you will run into performance issues with it, with your application. At least as soon as you put load on that application, you will run into performance issues for sure. So you have to know SQL, and then you have to, well, then depending on the framework you're using, you have to understand, okay, why are these SQL statements generated in that way? And then adjust the API calls or the statement that you wrote yourself. And I would say in every enterprise application using Hibernate or Spring Data JPA, you have at least a few native SQL statements. And that's totally fine. The JPA specification and Hibernate were not designed to replace SQL. They were designed to provide an object relational mapping that maps your records in the database to Java objects. But you definitely see in the entire API design that it is intended to be used together with SQL because, well, there's, for example, the create native query method that expects a SQL statement as a string. And yeah, that's intended to be used for all complex statements.
On the other hand, sometimes I do see developers using Hibernate, but then all the queries they use, they are native queries. What do you think about this approach?
Yeah, that's quite often an indicator for maybe a questionable framework decision in the beginning. If you just have to write native queries all the time, then quite often you used Hibernate for for an application that should better use, I don't know, Juke or JDBC template or something like that, where you have more control over the the SQL, the SQL statement you're executing. And quite often that's not just because you're executing queries, native queries. Quite often in that case, you also avoid the mapping to entities, or you recognize, okay, I have to execute lots of native SQL statements, and the mapping the result then to entities and to reversing associations actually doesn't really fit the use case. So in that case, it's quite often just the wrong tool for the job. You can, of course, implement it with Hibernate. Technically, it works. It's just more painful than using a different framework. So it's in the end, it's totally up to you what you want to use.
I think in the majority of cases, it's also because people find it difficult to learn at the beginning the JPQL.
Yeah.
It's a little bit different than the native, and somehow they feel they feel it uncomfortable, and then they decide using what they know instead.
Yeah.
But yeah, of course, not necessarily the right approach. So we have a question about in Hibernate, it's pretty hard to write mapping of queries with result set mapping. Juke is very query DSL, or query DSL gives you much better. What do you think about this?
Yeah. Let's say result set mappings in the Jakarta persistence specification are not my most favorite feature. So you use them to define a custom mapping from a native SQL statement to some object structure. That can be entities, that can be any kind of other objects. And there you always define the mapping of one record in the result set to one data structure. And yeah, all of that works. What feels not right to me in that case is that you have a native SQL statement as a string somewhere, and then you have a bunch of annotations that are nested in each other that then define how to map each field in the result set to a property on a DTO class, for example. So yeah, I totally agree there with Vintage that Juke, for example, does that mapping better than Hibernate does. But we also have to say, if you want to map the native query result to entity objects, then Hibernate can do that out of the box as well. As long as the fields in the result set have the same names as the database columns that are mapped by the entity class. Then you can just apply the same result set mapping. One other thing that you could use in that case is you could implement a result transformer. So result set mappings are a feature defined in the specification, so you can use it with Eclipse link as well, for example. In Hibernate 4 and 5, it was called result transformer. Now it's called a tuple transformer and a result list transformer. Team split that all the interface up into two interfaces. Long story short, you can implement your own result set mapping as Java code. And Hibernate includes a bunch of default implementations there. These are quite often easier to handle than the result set mappings, I would say.
And then we have a question about MyBatis. What the heck happened to MyBatis? I mean, are we still using it? I remember years ago it was iBatis and then MyBatis, and then it was like dark. I didn't hear anything about iBatis and MyBatis anymore.
Yeah, to be honest, I don't have a lot of experience with it. So I'm from Germany, and it feels like in Germany there's not really a huge market share for it. It feels like that in French-speaking countries, it has a little bit more traction, or had a little bit more traction in the past. I don't know if that's correct. It's just what it felt to me, where the requests were coming from. I don't know. I haven't really used it a lot. So yeah, can't really say if it's a really simpler approach than using Hibernate, because well, all my experience is playing around in some sandbox projects and reading a blog post. And let's be honest, if you read blog posts for 15 or 20 minutes on the beginner level, more or less every framework looks simple, right? The question is it simple if you have a few thousand lines of code and code that runs in production or not? And I didn't have a MyBatis project in production, so can't say much about that. Writing plain SQL is the other alternative. Well, if you want to use SQL statements and write everything yourself, I would say use Juke or maybe JDBC template. I wouldn't use SQL, self-written SQL queries over JDBC. It's just too error prone and clunky. So yeah, if you're using Spring, I would say Juke or JDBC template. If you are not using Spring, then I would suggest using Juke.
Or Spring Data JDBC, I think it also makes a good choice.
Yeah, but with Spring Data JDBC, you again have an object relational mapping and all these domain-driven design aggregates, and there you have to decide, okay, do I really want that? Is that the way I want to design my application? If yes, yeah, then Spring Data JDBC is cool. If not, then yeah, Juke is the more flexible approach, maybe even the easier.
Okay, from Jacket, what are your thoughts on native queries over JPQL?
Good question. I would say most applications need both. So when starting to think about a query, I usually start with JPQL because there we define our query on top of our entity model, and that means we have all the mapping features in place. Result mapping is easier and everything, but we can use just a small part of the query capabilities of your database. If you think of all the query features a SQL Server, an Oracle database, or Postgres has, then you can think of, let's say, such a feature set. Just a much smaller part of that is defined in the SQL standard, and JPQL just implements just a subset of that. So that's good enough for most basic queries, but not good enough for the complex ones. And well, I wasn't part of the JPA expert group, but as far as I've read and heard, it was never intended to define a query language that is as powerful as SQL. And that makes total sense because the only language the database understands is SQL. So it doesn't make, at least from my point of view, any sense to try to define a JPQL query language that is at least as good as SQL, because it can never be better. You have to translate it to SQL anyways, right? So I think it was a good idea there to define a query language on top of SQL that uses the entity model and then allow an easy way to execute SQL statements for everything that's database specific and too complex for another query language. So yeah, start with JPQL, see if you can implement it with that. Decide for yourself if you have to rely on the feature set defined in the Jakarta persistence standard or if it's fine for you to work with Hibernate specific features. If you can use all Hibernate features, then you can do much more than with the standard JPQL features. But sooner or later, you will get to the point where you have a query that's too complex. In that case, using a native statement is totally fine.
You have some question about post on your blog.
Okay.
So something with I have one-to-many relationship with figure fetching. I think you know better because you wrote it, no?
Yeah, the one about soft delete from Jack.
Yeah,
Yeah,
exactly.
okay. So Jack recently read on LinkedIn about soft delete in Hibernate, but if I have one-to-many relationship with eager fetching, then is it going to exclude soft delete many sites entity? Yeah, it does. So Um, let's take a step back. What is soft delete? Soft delete means we are not removing records from the database. We have a flag on that record that indicates that the record is deleted. So we are technically hiding the record instead of removing it. We have been doing such things for, I don't know, ages. Until Hibernate 6, the only way to do that, or I think until 6.1, the only way to do that was to use an update annotation on your entity, no, delete annotation on your entity class to tell Hibernate that it shall use your SQL statement as a delete operation. And instead of deleting, we used then a SQL update statement that changed the flag. And we had to add a filter that Hibernate then, so that's the Hibernate feature that adds a SQL snippet to all query statements, and there we had to add this filter that then exclude everything that has the deleted flag equals false or something like that. Starting with Hibernate, I think it was 6.1 or 6.2. All of this is provided by just one annotation. You put one soft delete annotation on the entity class, and well, the rest is just a built-in Hibernate feature. So it manages the flag, it replaces the delete with an update statement, and excludes everything. And the interesting part there is that it automatically adds this query predicate that checks the deleted flag to each and every query. And that was something that in the past, using a filter, quite often created some issues. Because, well, if you have to do it yourself everywhere, then it's quite error prone that you miss something. And now Hibernate handles all of that internally. It's much easier to use.
What do you think, Thorben? I mean, which would be, from your experience, some of the biggest mistakes developers make when they implement their persistent layer, regardless of the framework? I mean, whether it's Hibernate or something else, what are the biggest mistakes you've seen out there?
I would say two things. The first one is ignoring that you're working with the relational database. It's something that we see quite often as a promise of all kinds of frameworks, as they're abstracting from the underlying layer and you don't need to worry about that. Yeah, sure, technically we have an abstraction and everything, but we are integrating two systems, a relational database and our Java application. And we can now put technical layers on top of each other and stack them up as long as we want. But in the end, there is a table in a relational database, or quite usually a few hundred or thousand tables with lots of data in them. And we are sending a SQL statement to that database. And if we don't make sure that we have a table model that can be officially handled by the relational database and SQL statements that work on that table model efficiently, then we will not be happy with the results. At the same time, we should always have in mind that we are implementing a Java application that has to work with the queries and the result it gets back. So that is quite often something where we have a little bit of conflict between database needs and application needs, and we need to find good middle ground there, making sure that both systems can work fine.
And is there a best way in which you can test your application prior to delivering features to production, such that you avoid these issues?
Yeah, that ties in a little bit with the second point that I wanted to make, and that is ignoring the SQL statements we are executing. So my recommendation there is, if you change something, monitor the SQL statements that you're executing, check that it makes sense, and then have an automated test that uses a production database dump or something that's at least very close to. I know we're quite often working in environments where you can't just pull a dump from production because it contains sensitive data, or it might be too huge or whatever. But yeah, try to get an anonymized version of that and have a dedicated test suite that runs the most common operations you see in production and make sure that it works. Because that is the only thing our users care about. They don't care if the new feature is fancy. They don't care if it worked in our machine or on the unit test run on our Jenkins instance. They just don't care. They want to see it working in production and with production data. That's the only thing they care about. And sure, running tests on production data and on a production scale is complex and requires lots of resources. But yeah, that's the reason why we are not running that on our development system, right? That's why we have a Jenkins task somewhere at the end of our pipeline that does that. So yeah, I would say the most important recommendation there is check which kind of operations are critical in production and try running them on a test instance with a database dump that is as close to the production data as possible.
Cool, thank you. Good, very, very good advice. Thank you very much. So I think the next question you will definitely understand better than I do. So from Fernando, he's asking us, what is the most efficient way to obtain projections from a master detail relationship?
So with the master detail, I expect that Fernando has something in mind where we have at least two database tables and a one-to-many association between them. So there are two ways. You could use a DTO projection. The benefit there is, and I'm expecting you are using Hibernate or Spring Data JPA. So you could use a DTO projection there, and then that one has the benefit that you can clearly define which columns you want to fetch from the database and only fetch these, and you don't have any management overhead. In general, that's the most efficient projection because you can fine-tune it on the needs of your use case. With master detail, the downside there is that you get a DTO object for each record in the result set, and that means you get master with detail with one child records, the same master with the second child record, and so on. And yeah, that's I just saw he posted that he's using Spring Data. So if you're using Spring Data with a relational database, then we're most likely talking about Spring Data JPA. So yeah, this DTO projection is in general a good fit. The downside is that you get multiple records that all contain the same master information. It's quite annoying. If you want to use entities as your projection, and that will mean you're fine with fetching all columns mapped by that entity class, then you should join fetch the association from master to detail. And you define that in the from clause. Basically in the same way you define just using the additional keyword fetch, and that tells to fetch both entities that are part of this relationship. And that means all of the columns are added to the select clause, and then your JPA implementation takes this whole bunch of data and creates the object structures out of that. So yeah, the join fetch is there most likely the best approach. Just make sure that all other relationships of your objects, of your entities that you're fetching there are fetched lazily so that fetching your master detail relationship there doesn't trigger a bunch of additional statements to fetch lots of other related entities. That's usually the beginning of huge performance issues.
There's also a question there about common anti-patterns. So besides post filter and DB query, post filtering, I mean, why did they even add that method, the Streams API support in the, you know what I mean? Now people are usually now selecting everything, and then you have now Streams API, so why not filtering?
Yeah, right. To be honest, we had the situation that people select just everything from the database also before we got the Stream API, right? But yeah, now it just looks better. It's just a more fancy way to create the same mess. So yeah. Why did they add the get result stream? I would say because we as the developer community wanted it. asked for it repeatedly, and I mean over and over again. And in the past, before that method was there, people just got to fetch the result list and then created a stream out of it, which breaks the whole stream idea. I mean, if you're streaming something, you expect that you go through that bunch of data that you got there, and you most likely just stream it from the database while you are processing it, right? Yeah, wrong in most cases, especially wrong if you're using calling the get result list method and then convert it to a string, because that means you tell Hibernate to get the result as a list, as a fully initialized list, which means fetch everything from the database, put it into a list, and then call the stream method on it. So then they added the get result stream method to the API, and at least with Hibernate, so the Jakarta persistence specification makes it optional how the implementations implement the get result stream method. The default implementation uses the old approach, fetching a list and converting it to a stream. Hibernate uses a scrollable result set, and that one really scrolls through the query result. So that fetches a record from the database and then feeds it into the stream where it gets processed. That thing is a little bit tricky. You should pay close attention to how your database handles the query and provides the result. But as a general idea, that could provide some performance benefits, as long as you do all the filtering on the database, because that's why we are still using databases. These systems are dinosaurs of our industry, right? I mean, they are several decades old and as still the dominating system to store information. And that's because they are really good in filtering and transforming data, and we should use it for that. So please don't do that in streams. But yeah, if you let the database handle all of that, then using the get result stream method and then processing the result as a stream can make sense. Yeah, but I think the main question was what are some common other anti-patterns we're working with?
Other, yeah, besides the post
Yeah.
filters. So do you know others?
So I would say another where we started talking about Spring, so the open session in Vue is a huge anti-pattern. It was something introduced in Spring Boot. The idea there is that on your API level, you open up the session and then you get into your business layer. There you open the transaction, do all the processing, commit the transaction, hand over the result to your API layer, and that one still has an open session. That has the benefit that if you returned entity objects from your business layer, then which had uninitialized, lazily fetched relationships, then the open session that your API layer still has allows you to fetch the relationship from the database without getting a lazy initialization exception. So they basically put a band-aid on the wrong handling of relationships that creates all kinds of issues. First of all, you fetch the relationship out of the transactional context that you had in your business code. And that means your query could return different results. If things go bad, then your business code fetched a relationship or did some operations on the database, read some data, and said, yeah, we have three child records, and these, but didn't fetch them from the database. And when then your API layer fetches the lazy fetched relationship afterwards, it might get 4. And you're basically showing your users, yeah, we have 3 child records, and then you show them 4 below, directly below that. And well, let's say it could harm the trust of your users in your system. I mean, you just showed them that you can't count to 4. So might not be the best idea. And it puts a lot of load on your database because all the additional relationships that you fetch, open up a transaction, fetch the data, close it again, and that puts, yeah, unnecessary load on the database, which is great. Another anti-pattern that I see quite often is using entities for everything. Entities are great if you want to modify data. They're not that great if you just want to read them, because entities are always fetched with all their properties. That means all columns met by the entity get selected. And well, if you look at most projects, they have entities with 50 to 100 of attributes, and that means 50 to 100 columns of database table get fetched, even if you just need 2 of them. And that's obviously not the most efficient approach. Another common anti-pattern, so better for read operations are DTOs, which are unmanaged objects that you can design for your use case, and you should design them based on your use case, which means you will have quite a lot of them. Using Spring Data JPA, you can do that as a simple interface or as a record. When working with plain Hibernate, you can sorry, you can use Java records, for example. Other anti-patterns, when working with entities, not initializing the relationships when fetching the entity. Another anti-pattern. Oh yeah, a typical Spring anti-pattern is that is some, well, not sure if it's an anti-pattern, it's more of a wrong usage of the API. It's calling the save method after modifying an entity, or even worse, save and flush.
Yeah, I saw that. I mean, a lot of developers, they don't get that simply ending the transaction does the modification. You don't need any save method, no?
Yeah, and that is something, or one of the reasons why I said you should learn about this tag in a structured way, because to understand why you don't need this to call it the save method, you need to understand how the entity lifecycle model works. And that is that your persistence context has a reference to each entity object you fetch from the database, and if you execute a query or commit the transaction, your JPA implementation takes a look at all these managed entities, finds the ones you modified, and then decides if it now has to execute the update statement or if it can delay it a little longer.
Also,
The only guarantee you
consequence. No, go on, sorry.
Yeah, the only guarantee that you have there is that all write operations will be performed before you commit the transaction. Yeah, the second trigger would be that you execute a query for that uses a database table on which you made some changes. Then these changes will also be flushed to the database. But yeah, then in many Spring Data JPA applications, you see people calling the save method because, well, it sounds reasonable. I made a modification. I want to save something, so I call the save method. Yeah, it's totally unnecessary. It just burns a few CPU cycles. If you dive into the implementation, you see that the implementation of the save method checks, is it a managed entity? And well, the repository implementation calls the entity manager, and that one at some point checks, is it a managed entity? And if that's the case, then it just returns. So you go down several method calls on your stack trace until you get to the point where it's checked that if it's a managed entity, and if that's the case, you just walk up again. And you did nothing except for heating up your CPU a little bit. Gets worse if you call the save and flush method, because that forces Hibernate to flush the persistence context, which means the all modifications that you have performed on entities that were not written to the database yet get now written to the database. And I rarely see that being a good idea. I mean, the Hibernate team and the Eclipse Link team as well have this entire lifecycle management concept implemented since the beginning, more than 20 years in the case of Hibernate. And it's performance critical. They've put a lot of effort into making that part as efficient as possible. You will not beat their optimization unless you have a very, very strange application, in which case you should probably think about using a different framework in general. I've never seen this being a good idea.
Another,
But yeah, I would say these are the most common anti-patterns.
another consequence, of course, of misuse may be the n+1 query problem. No, I see that quite often happening. People not managing well their joins or relationships.
Yeah, that's why I said you should always fetch the relationships you need. So when fetching an entity, you can use a join fetch clause or an entity graph to define which relationships do I need. Let's say I'm fetching books from the database and I know I need the authors who have written the book. Then I can do select B from book B, join fetch b.authors. And then all columns mapped by the authors and all columns mapped by the book are selected by the query. And you have a where clause that makes sure that you only fetch the authors who have written the book. And then you get everything in one query.
So, Thorben, we are quite some time already into our podcast, and I think it's time to close soon. I wanted to let you the chance if you want to choose one more question, because I think the questions still continue flowing. And
Yeah.
we're very happy, guys. Thank you very much for all the questions. And we will try to answer one more now, but then we'll have to let the others. But we are still looking for them in the comment section after the video. So, any other question you'd like to answer?
I would like to pick two because one is very quick. There's one question about configuring multiple data sources for an application, if there are any pitfalls. No, you just have to use XA transactions, and you need to be aware that one persistence context, so one group of entities, are always bound to one data source. Besides that, shouldn't be any major pitfalls. And then Igat wrote, how does singleton repository bean handle concurrent DB queries? I understand each thread has its own stack to hold variables, but why does this work in high traffic systems? The main thing is that the repositories internally use an entity manager or a Hibernate session that is an entity manager, and that one is bound to one transaction which gets processed by one thread, and so each and every one of them then has their own transactional and database connection context on which you execute the query. So in that case, your dependency injection frameworks make sure that each repository instance that you get in your business code is initialized with the right entity manager that is connected to the transaction that you started at the well, hopefully at the beginning of your business code. One pitfall there is if you introduce asynchronous service calls, these are executed in a separate thread. These get a new entity manager, new transactional context. That is something that you should pay close attention to. But yeah, talking about all the pitfalls that you get with this asynchronous processing is something we probably need another hour for. So I would only say, okay, make sure you understand how your transaction framework works and what asynchronous processing there actually means. Yeah. Okay. Then I would say thanks for all the amazing questions here in chat.
Thank you very much, everyone. So this was excellent. And okay, of course, thank you very much, Thorben, for being here with us. As we thought, we have learned a lot of things, and it was a very informative session. Guys, thank you again, everyone. You are awesome. Thank you for all the questions and interactivity, and see you on the next events. Have a good rest of the day, everyone. Cheers.
Bye.
Okay, we are out. Thank you very much, Thorben. So it was amazing.
That was great.
So
Yeah.
how many people